Hey everyone, today's lesson is all about finding the equation of a perpendicular line. So for question 2, our first example, find the equation of a line that is perpendicular to y equals x over 2 has a y-intercept of -2. Let's revise how to actually draw this line first. Whilst this is actually not needed, it's good to actually just see what the context is, okay, before we do everything that algebraically. So if we have a look at the actual equation, x over 2 can actually be written as half x. They mean exactly the same thing. So in this case, m1, the gradient of this line, is half. Okay? So if I was to draw this equation, okay, you know that y is equal to x over 2 is the same thing as y equals half x plus 0, where this is our y-intercept. Okay? So that means we start from a y value of 0, which is right here. And what we're going to do with that is we're going to go up by 1 and right by 2, just by looking at the gradients. So there's my new dot. Okay? So if I then use that new dot and join it out with the original dot that I have, like that, I'll have this line. So this line resembles y equals x over 2. Now it's saying here that there's another line that is perpendicular to this and has a y-intercept of -2. So y-intercept of -2 will be right here down the bottom, 2 units below the origin. And if it's perpendicular to it, then it has to meet up at 90 degrees, which means it looks like this. So that if you have a look at between the part where it intersects at 90 degrees right there. So how do we actually find this equation? We need to find the gradient that is perpendicular to this. So the line y equals x over 2 has a gradient of half. Okay? So what would the gradient of the line perpendicular to it have? It would be the negative reciprocal of this. Okay? Which is negative of 2 over 1, which is -2. Okay? And I'm going to write that here. So m2 is a negative reciprocal, which is -2 over 1. That's -2. Now our y-intercept here that we need, okay, of that new line is -2. So b equals -2. And now let's form our equation, which is y equals mx plus b. We can now replace m here by -2 and also b here by -2. So y equals to -2x minus 2, and that's the equation of this straight line. Alright, question B. Y equals -5x. Let's find out the gradient of that line. That means m1 equals -5. And m2, which is the gradient of the perpendicular line that we're going to find out, is going to be the reciprocal of that one. So the gradient of -5 is the same thing as -5 for 1. If we flip that around, we get 1 over 5, and we've got to change the sign from negative to a positive. Alright, so we've found out our gradient. The next thing we've got to find out is our b value. But this is no b value, this is our x-intercept. An x-intercept means where it cuts the x-axis, and this is the same thing as 1, 0. Okay, let me show you what this means. So the line y equals -5x, okay, has a y-intercept of 0, right? This one has a y-intercept of 0 because it has a plus 0 there that you can't really see. And a gradient of -5 over 1 means go down by 5, like that. It's a rise of -5, and run by 1, like that. So if we go down by 5, then right by 1, we'll be right here. So if we join it up to the original dot that we had, right there, okay, we get this straight line, like that. And that is y is equal to -5x. So the other line must pass through this point here, right there, which is our x-intercept. Now, this x-intercept, which is on the x-axis here, okay, has a coordinate of 1, 0, because it's just 1 to the right of the origin, but 0 units up or down from there. So we have to join that up with a point on the other line such that they intersect or they meet at 90 degrees. So I'm going to try my best to do that. That's what I've done. So see how this is 90 degrees now? Okay. That's what we're going to do. And now we've got to find out the equation of this line. So we know y equals mx plus b. Right, that's the equation of the line. But we're going to substitute in m2 as our m value here. So that y equals to 1/5 of x plus b. But now what we've got to do is find what b is. And to find what b is, we have to substitute something to do with x and y so that we can solve for an equation involving b. That involves this coordinate here, which has our x and y value that we substitute in. So if we substitute in y as 0, that's equal to that's equal to 1/5, of 1. Okay. And that will be plus by b. So 0 would equal to 1/5 plus b. And now if we move 1/5 to the other side, okay, by subtracting both sides by that 1/5, okay, then we will get b as -1/5, basically. Okay, since those two cancel out. All right. So once we're done with that, we can now put this back into the equation. So if I put that b value back in there, then y would equal to 1/5 of x minus 1/5. Okay, and that's our equation of that light blue line. Okay, and that's perpendicular to this line. All right, let's move on to question C. Y is equal to 3x minus 1 and passes through the x-axis at 4. Okay, so if it passes through the x-axis at 4, what kind of coordinate is that? Let's have a look. That will be this coordinate here. Okay, so this coordinate has a coordinates of 4, 0. Now, our line has to be perpendicular to this line. Okay, so this time what I'll do is I won't draw that anymore because we don't actually need it. We can just do everything algebraically. M1 in this case is just equal to 3, the number before the x. Okay, which is the same thing as 3 over 1, if you rewrite it that way. M2, which is our perpendicular gradient, is -1 over 3. It's a negative reciprocal of this number. Our new point that we've got to use for our working out is 4, 0. I'm just going to write that there. And the equation that we need to find is y equals mx plus b, containing the gradient of the perpendicular line to this. So if we substitute in m as -1/3 in there, plus b, like that, and then replace x by 4, y by 0, zero would equal to -4 over 3 plus b, which means that if we plus 4 over 3 to both sides, like this, we get 4 over 3 equals b. Okay? So that's the second most important part, because now that we found that, we can substitute it back in here, and that lets us find the equation. So that y equals to -1/3 x plus 4 over 3. Okay? And that's our equation of the line that we need. All right, question D. Y equals to x over 3 minus 6 over 3. And passes through 186. All right. So our first thing to find out is the gradient of this line and find the negative reciprocal of that. Okay? But this is not written in the equation y equals mx plus b. We need to firstly do something to this so that we can find out the gradient. Each of these things on top okay, the x and negative 6 are both divided by negative 3. We're going to write x first over 3, okay, so we're dividing this by 3. Then we've got to write minus 6 divided by 3. So basically what we're doing is we're splitting the fraction, okay? These two actually minus to give you this still, because it's the same denominator, meaning the numerators can be put together over one single denominator like that. So what we can do here is I would like to simplify this as well. 6 over 3 is 2. Not that we really need it, because all we're trying to find out is the gradient of this line, which is 1/3. And the gradient that is perpendicular to this, M2, is the negative reciprocal of this, which is negative 3 over 1. And that's the same thing as negative 3. So, once we find our m value, we need to find our b value. Let's write down an equation, y equals mx plus b. And we will substitute in m as negative 3. So here's my negative 3, x plus b. And we're going to substitute in x as 1, y is negative 6. So there's my y is negative 6, and x is 1. Okay, like that. So that negative 6 is negative 3 times 1, which is simply negative 3 plus b. And if we add 3 to both sides, then this will cancel. So therefore, b is simply negative 6 plus 3, which is negative 3. And since we have these two values here, b is negative 3, and the m value is negative 3, we can put that together into that equation, so that y equals to negative 3x minus 3. That's our equation of our perpendicular line. Right, moving on. Question E. X plus y minus 6 equals 0. To find out the gradient from this equation, we need to firstly put it into gradient intercept form, meaning that we need the y to be by itself. This means that x and negative 6 doesn't have to be on this side of the equation. We can move it to the other side. Okay? When a positive x moves to the other side, it just becomes negative. When a negative 6 goes to the other side, it just becomes positive. So y equals to negative x plus 6 is what I'm saying. Okay? Then our gradient of this line, m1, is equal to negative 1. Okay? That's the number before x. m2, okay, will be a negative reciprocal of this. Now, negative 1 is the same thing as negative 1 over 1. If we flip this around, okay, and find the reciprocal of this, we will get 1 over negative 1, but we don't want the negative to be there because we get the opposite sign. So it's just 1 over 1, which is the number 1. Okay? So now we're ready to find out our perpendicular line by writing y equals mx plus b and substituting in an m value of 1. So y equals 1x plus b, or y equals x plus b. Y in this case is negative 4, and x, y in this case is 2, and x is negative 4. So we're going to substitute those values in. So that 2 equals to negative 4 plus b. And now adding 4 to both sides, like that. This gets me b equals to 2 plus 4, which is the number 6. Okay? And now y would equal to mx plus b, where m is going to be 1 and b is going to be 6. So y would equal to 1x, which is x anyway, plus 6. All right, that's our equation of a perpendicular line. Okay, let's go through F. So for question F, we've got 3x minus y minus 9 equals 0 and passes through negative 10, negative 7. So again, this equation here is not written in gradient intercept form. So let's put it in gradient intercept form first. We can do this really easily if the negative y can move to the other side to become a positive y. So what this means is you have 3x minus 9 on this side of the equation. If you move minus y to the other side, you'll have a positive y. Okay, and I'm just going to remove that positive because we don't need to rewrite that. And now if we just swap these two equations around, because we're allowed to do that, y would equal to 3x minus 9. Okay? So this means that our gradient of this line, m1, is equal to 3. And the gradient that is perpendicular to this, which is m2, would have the negative reciprocal of this value. So 3 is the same thing as 3 over 1. So the negative reciprocal of this will be negative 1 over 3. Okay? The equation of a line we're finding is y equals mx plus b. So m in this case is negative 1/3, and we're just going to put this right here. So y equals to negative 1/3 x plus b. Our y value in this case is negative 7. Our x value in this case is negative 10. So if we put our y value as minus 7, right there, and our x value, which is, we're going to multiply by negative 1/3 by the way, by negative 10, we get this result. Okay, right there. Okay. So then we have to multiply this negative 1/3 with negative 10, which is positive 10 over 3 plus b. And if we subtract 10 over 3 to both sides, this will allow us to find what the b value is. Okay? So negative 7 minus 10 over 3 will give us negative 31 over 3. And that's simply equal to b. So now we've got the two values that are most important to us, our b value here, the y-intercept, and the gradient, which is negative 1/3. We can put that together and put it into this equation so that we replace m by that and m and b by this. So our equation would equal to y is equal to negative 1/3 of x minus 31 over 3. Okay?